Good afternoon.
Hello, Dr. Chen.
So shall we start it?
I have a question about the homework.
Yes.
I'm sorry, my connection's kind of weak, and I apologize. Does the homework normally involve this much integration by parts? Because I don't have MathCAD to really speed this along. I have to do a lot of it. I have to do all of it by hand.
Yeah, you don't need MathCAD. You can integrate by hand. It's a little bit more troublesome, but it's still manageable. Do you agree?
It's long. I mean, the integration by parts normally takes me a while.
Yeah, can you do at least one or two problems?
But I was just wondering.
Okay, let's do this. Can you do one or two problems just to show you know the concept? You can get.
Oh no, yeah, I can do the problems as far as like the book is, you know, the Fourier.
Okay. Okay.
Yeah, I can do all that. It's just it's taking me a while to do the integration by parts to check the
I know.
solutions. So
Your handheld calculator doesn't do the job.
oh yeah, it does. It just takes a while.
Uh-huh. Okay. Do one or two. Do as many as possible, and I would tell the TA to be gentle.
Understood.
Yeah. By the way, I did tell. I had a communication with him this morning after our meeting. He said that he has an exam tomorrow. So right after the exam tomorrow, he will start grading the exam. So you should get it by tomorrow evening. He's a very efficient person.
Understood.
Okay. Any other questions?
That was the only question I had. Was is it supposed to be normally like a lot of integration by parts, but that was the only question I had.
That's a real dog there.
Yeah, that's one of my two dogs.
Okay, you have good company.
Great alarm system.
Yeah, yeah. If you want the short answers for the even problems, I can give you the answer.
Dr. Chen, this morning you said that it would be okay just to do 3 terms for problem 1, right?
Okay, okay. Yeah, that's a good idea. Yeah, just do the odd numbers just to show you are capable of doing that. You know the concept. For which section? For both sections? For both sections or just one section?
I was just asking about problem number 1 in section 11.6, how many terms you wanted us to include in our answer.
Problem number 1 for section 11.6. Yeah, I wish you have MathCAD. It's so easy. Did you notice? Number one, it's a polynomial of fifth degree. So that means if you include 6 polynomials up to P0, P1, etc. to P5, you should get perfect fit. You should get exactly the same thing. And additional P sub 6, P sub 7 will not help. But if you increase the number from P0 to P4, you still see the discrepancy between the representation and the real function. So this is something. You understand the point I was making?
I think so.
Did I answer your question?
Yep.
Let me know if you still have questions. Yeah, you can do only odd problem for both sections. Let me see how many problems. 1, 2. 2 problems for the first section. And 1, 2, half. So I reduced the amount of effort to half.
So we don't have to do even numbered homework problems anymore?
Yes. If you understand the point, it's very important for you to understand the concept. So I will write an email to the TA reminding him that I reduce your effort to half for this round of homework. And he doesn't have to give penalties if students don't do those even number homework problems.
Thank you.
Hey, I know, Dr. I know everyone's not in this meeting, so are you going to send out an email that says that as well?
Yes, I will send an announcement to everyone, including the TA. Yes. Like I say, everybody is busy. I always want to be frozen at this moment. Any other discussions?
Hey, Dr. Chen, sorry. I joined a little late. What were you announcing just before about the homework being reduced?
To reduce the homework problems to odd number problems. So you have the short answers in the back. Just do the odd number problem.
Okay, I got you. Thank you.
Sure. Any questions? Any other questions?
For problem number 1 in section 11.6, could you
Yeah.
tell us what coefficients you got for, so we can see if we did it right?
So then number 1. Okay. Yeah, the short answer is you notice the author on page appendix 29, page 29 of the appendix, A29. You see the author used 5 polynomial, actually 6 polynomial from P0 to P5. And he found the even degree polynomial all disappear in the expansion. Only the odd Legendre polynomial exists in the expansion. So this could happen because the given polynomial is 5 degree in power. So we can include only 6 polynomial to fully describe the function. So this should be a perfect fit. But the other problem, let's say number 11 is not going to be a perfect fit. You're going to approach it. So let's see number 11. Yeah, they also use P0 through P4, altogether 5 polynomials. Yeah, it's too bad you don't have calculator. You don't have MathCAD. Otherwise, this was a simple problem. This will be a simple problem. Okay. Any other discussions? If you don't have a problem, that means we can adjourn.
Dr. Chen, one more question.
Yes?
Yeah, when I'm working on number 10, and I know that you said don't worry about the odd or the even numbered ones. I'm trying to figure out. I can't find it in my calculus book of how to integrate e to the negative x squared, and I'm trying to remember how to do it. Could you
Okay. Okay.
help me with that?
Good point. Yeah. Good point.
Because I keep coming up.
But
I know that I'm doing it wrong because I keep coming up with 0, and I know that it can't. The answer can't be 0. So
I
Hey,
believe
just go on Symbolab.
I believe you can use the integration by part.
yeah,
Now the question is how. Did anyone get it? Let me see the. I label a page, which is usually very useful to me. It has a lot of integration formula. Is it, if you have the internet access, can anyone check on internet? See if you can find the answer. It's e to the minus x squared times, say, x squared. If you can find, I'm sure the integration formula is in there. I still have the book, integration formula, here somewhere in my home. I was looking for someone to take it over. That's an integration book I had a long time ago. One was in college. Anyone who wanted, let me know.
You say integral of e to the x squared?
Yeah, that's number 10. I think that's James was talking about. E to the minus x squared times Legendre polynomial. That can be simply P naught or P1 or P2. So you are going to integrate this function, e exponential function with x to the certain power. You agree? To get the coefficient. Let me do some search. Let me Google it.
I tried putting it in Symbolab, but I got like an error function, and my calculator won't do it.
Ah, okay. Yes.
Yeah, that was the problem I was having.
Yeah, it's called arrow function. Yes. Now I remember. I learned arrow function when I was in college too. Okay. Integral of x to the e to the minus 2x times, say, x squared. Yeah, it give me a lot of hint. You can find this, yeah, how you do this by integration by parts. Let me show you what the links I use, what the keyword I use to find this. I Googled integral of this. You can find some hint by Googling. Okay, this is manageable. So nowadays you have internet. You don't need an integration table. Everything is available on internet. Good question, James. Any other questions?
That was the only question that I had, Dr. Ken. Or
Okay.
the only other question that I had.
Okay. Any other questions, comment?
Do you know when the test will be graded?
Can you say it again, please?
Do you know when the test will be graded?
I talked to the TA this morning after our session. He said he has an exam. He has been working on it, on the exam. So as soon as he finished the exam tomorrow, he will start grading it. So he hoped he can get the exam paper graded by tomorrow afternoon or tomorrow evening.
Thank you.
And this morning we discussed the final exam policies. Please make sure you watch the video already linked to the Blackboard. It's going to be on the 6th, Wednesday morning at 8 o'clock. I'm not sure if you heard it. Any other discussions? Shall we adjourn the meeting?
Thank you, Dr. Chen.
Okay. Thank you for joining us. You had good questions. And tomorrow, unfortunately, I have one big meeting started at 9 tomorrow morning. And the advisory board is coming in the afternoon, meet with the faculty at 2. So my time will be pretty much occupied tomorrow, but I'll try to respond to your question if you have effectively. Morning, sure. My my morning meeting started at 9, may last, who knows? It's related to a faculty's tenure and promotion. It's going to be pretty hectic meeting. And tomorrow afternoon, the advisory board is going to have another meeting. So I apologize if I don't respond to email effectively tomorrow.
Excuse me, Dr. Chen.
Okay.
Are we only doing the odd problems now on the homework?
Can someone repeat the question again?
I'll put it in the chat for you.
The test, which test? Exam 2 or the final exam?
She's asking if we're only doing the odd problems on the homework now.
Oh, yeah. Let's just do the odd number homework problems I assign to save your computational time. However,
Okay.
yeah, the important thing is to know how to do it. Just do 1 or 2 fully, so you gain the confidence. Yes, we are only going to do the art problems. I will write an email to the TA and then everyone else.
Thank you.
You're welcome.
Thank you, Dr. Chen.
Sure. So shall we have dinner now?
Yes, thank you.
Okay. Good luck. Have fun.